Hi, I'm Sagnik, and today I'm going to talk about a paper, Move to Here, Active Audio-Visual Source Separation, done in collaboration with Ziad and Kristen. Audio source separation involves separating a mixed set of sounds into one or more components of interest. This is nicknamed as the cocktail party problem, and we as humans try to solve it all the time. In this example, a man is in a very noisy party, but he is trying to just listen to the speech of his interest. Most present separation models, like the one shown here, use both vision and audio, but are passive in that they need access to pre-recorded videos for separation. In this paper, we try to extend this passive task to an active embodied one. We call this task active audiovisual source separation. The main idea here is to let audio and vision guide a navigating embodied agent's motion to better separate the actual hidden sound playing at a target source. For instance, in this cartoon, the man strains his neck to better listen to a sound that's of interest to him. Similarly, if an embodied agent could sample audio by moving not necessarily right towards the target sound, but to areas where the target is more dominant in comparison to the distractor sound, separation quality could be greatly improved. This could find useful applications such as improving the audiovisual experience in assistive augmented reality and enabling mobile robots to respond quickly to humans in noisy settings. Here we show an instantiation of the task where we have three active sound sources in the environment.
No, I don't. I've used playback in films before, and my mind has a tendency.
Stop talker, and she goes off in all different directions, and it seems complete chaos. But the more you look at the
Here we show the initial agent's egocentric view, the top-down environment map with the target circled in green, and play the mixed binaural initially heard by the agent.
No,
stop
I don't.
talker, and she goes off in
I've
all
used
different
playback in
directions, and
films
it seems
before,
complete
and
chaos. But
my
the
mind
more you
has a
look at the
tendency.
Through intelligent movements, the agent is able to move behind a wall to cut out the distractor sounds and better separate the target sound. And this is the final mixed binaural.
Great about the live singing
he
was
says
that
pounds the
it
dough,
allowed
pick
for
up the rolling
multi-camera
pin at this
shooting.
point.
And the target monaural prediction.
Great about the live singing
He
was
says
that
pounds the
it
dough,
allowed
pick
for
up the rolling
multi-camera
pin at this
shooting.
point.
Where the ground truth is,
Great about the live singing was that it allowed for multi-camera shooting.
this shows how in an environment with three sources all mixed together, our agent can move intelligently to hear the one of interest more clearly, approximating what is the ground truth isolated sound. In our experiments, we consider two versions of the task: near target, where the agent is co-located with the target source, and far target, where the agent starts at a location distant from the target. While near target requires the agent to make fine-grained movements to improve separation, far target requires it to initially travel towards the target before making finer adjustments. We solve both of them using RL. The most important attributes of an episode are the K monaural sources of different audio types, the target audio type, and the episode time budget. The action space includes move forward, turn left, and turn right action. We evaluate the task using the Matterport 3D scenes and the SoundSpaces audio simulations. This is our approach for near target. We use a three-stage target audio separator network. The first stage takes a mixed binaural audio and the target audio type as inputs and predicts the target binaural. The second stage converts the predicted binaural into the corresponding monaural. The third stage acts as an audio memory and refines the monaural predictions by aggregating them over time. The other component of our approach is the active audiovisual controller. This is tasked with predicting actions to control the agent's camera and microphone placements for improving separation. We inject the separated and memory-refined monaural, the separated binaural, and the egocentric RGB observations into a standard RL navigation framework and replace the navigation reward with an audio separation reward to encourage improvement in separation over time. These two components are trained cyclically using PPO. These are our main results. Move to here outperforms baselines that navigate to or stay at the target, move around near the target, or try to cover as much area as possible and sample diverse audio. Interestingly, we observe that just reaching the target isn't enough and fine-grained motion is necessary for high-quality separation. We also notice that our novel reward design successfully encourages the behavior of improving separation quality over time in an episode. Further, Move to here generalizes to unearth sounds much better than all baselines. Here is a sample episode of Move to Here for near target. The monaural ground truth is
And it was so thoughtful.
the initial mixed binaural that the agent hears is
Movie together.
It was so thoughtful. It was so thoughtful. And it was so thoughtful.
we see that the agent is able to make use of its movements and the surrounding obstacles to find a sweet spot for hearing the target more clearly. For more results, code, and data, refer to our project page. Thank you for watching.